Hello, today I want to talk about the recursion function. What's this and how we can use it and why we should use it. Recursion function actually is a kind of function that calls itself in itself. So actually it works like a loop. So not exactly like a loop, but we can say it's work like a loop. So how does it work? If we let me see an example. For example, this function lemoning um, call itself. you know so if we run this program, this should be a problem. Exactly, the problem is that there is no end for this function. So let's see. As you can see, there is no end for this function. So how we can fix it? How we can use it? So in this way, we can reach this point that for every recursion function, we need the condition that in that condition, the loop should stop. But there is a point. How we call that condition? In recursion function, we call that condition as a base. So it means in every recursion function, we need a base. And in that base, we need to stop the function. So look at this example. Yeah, factorial. Factorial is the base example for a recursion function. So in a factorial, when we should stop the function? Exactly when x is equal to 1. It means we don't need to multiply the numbers again. But if the x it wasn't equal to 1, we need to continue the factorial function, and it would be the else condition. The condition that we should continue the factorial function. As you can see in this example, I called the factorial function in the factorial function. So let's look at this function again. So as I said, we need to have a base, and in this case our base is when x is equal to 1. It means we have to stop the loops, we have to stop the recursion function. And also we have a condition that in this condition we need to continue the loop, continue the recursion function. Okay, so let's look at this example. For example, factorial 5, it would be equal to 5 times 4 times 3 times 2 and times 1. And when we look at our example, our function, we can see obviously that x is 5. That multiply by factorial of one step before, and one step before it would be equal to 4 factorial, or 4 times 2 times 1. So let's test our function, for example, for factorial 5. Okay, as you can see, when I run the program, factorial 5 could be equal to 120. That is exactly true. So something that was happened here is that each time that I called factorial function multiply x by factorial function one step before that. It means x minus 1. I hope you really enjoyed the video and it was useful for you.